Welcome back to the Python Praxis. In the first part of this lesson, we discovered how the for loop helps us repeat actions over sequences for a fixed number of times. We have also seen the use of ranges and for loops. Now, in this second part, we will continue exploring one of the most fascinating ideas in programming, loops and repetition. We'll dive into the while loop that we use when we do not know exactly how many times something should repeat. We will explore how to break or skip parts of a loop and learn about the hidden else feature in loops. By the end of this video, you'll see how these pieces work together to create programs that adapt, react, and make decisions on the fly. Let's begin. Sometimes in programming, we want to keep running the same block of code over and over again, as long as something is true. That's where the while loop comes in. So, what is a while loop? A while loop allows us to repeat a block of code as long as a condition remains true. It keeps checking the condition before each repetition. Here's the basic syntax. First in the line is the word while. This is a Python keyword, and it tells the interpreter we're starting a loop. Next comes the condition, followed by a colon. The colon is very important in Python. It marks the end of the loop header and tells Python, "Get ready, the next indented block belongs to this loop." And finally, we have the indented block of code. This is the set of instructions that will run in every repetition. Do not forget, indentation is not just style in Python, it is syntax, so always make sure your indentation is correct. How does it work? Step 1, Python checks the condition. Step 2, if it's true, it runs the indented block of code inside the loop. Step 3, after the block finishes, it goes back up and checks the condition again. Step 4, if the condition is ever false, the loop ends and the program continues with the rest of the code. Always remember the two key rules. Don't forget the colon, after while condition. And the code inside must be indented properly. Watching now the flow diagram of a while loop, we see the steps. Python executes all previous statements that are before the loop. Then a while loop starts by checking a condition. If the condition is true, then it executes the indented code block of the while loop. When the condition ever becomes false, then the loop ends and the program continues. This is the flow every while loop follows. Here is an example where we use the while loop to count. Let's break down the code. We start with counter equals 1. Here we create a variable called counter and we initialize it to 1. This variable is our counter. Then we have the while loop that starts with the keyword while followed by the condition. The condition, counter is less than or equal to 4, is checked. Since it's true, Python enters the loop. Inside it prints loop number 1. Then counter increases by 1. This repeats until counter becomes 5. At that point, the condition is false and the loop ends. So the output is loop number 1, loop number 2, loop number 3, and loop number 4. Be careful though. If you forget to increase the counter, the condition might stay true forever, creating an infinite loop. And trust me, every programmer hits this bug at least once. So, when making loops in your code, pay attention to these important points. Do not forget the colon. After the while line, the code inside the loop must be indented properly. These repeated lines are often called the loop body. If your condition never becomes false, the loop will run forever. Infinite loop. Let's walk through a small but very useful program, a movie night data tracker. You must create a Python program that tracks a user's movie watching habits. The program will apply concepts from loops, lists, user input, and conditional exit. What your program should do: ask the user to repeatedly enter movie ratings 1 to 10, one at a time. Use a while loop to allow repeated input. If the user types done, the loop should stop. Store all the valid ratings in a list. After exiting the loop, display the total number of movies rated. Print the average rating rounded to 1 decimal place. Show the highest rating the user gave. Let's dive into the code now. In line 1, we start by creating an empty list named ratings. This is where we'll store all the valid ratings the user gives us. In line 2, we ask the user for input. They can enter a number from 1 to 10 to rate a movie, or type "done" to finish. In the next line, we begin a while loop that repeats as long as the user hasn't typed "done." This lets us collect multiple ratings in one run. Next, we have an if conditional, if user input is digit. In this line, we check if the input from the user is made of digits only. If it is, in the next line, we convert the string to an integer and store it in variable rating. After this, we have another conditional, nested. We validate whether the input from the user is in the valid range. Only numbers between 1 and 10 are acceptable. If it's valid, we add the rating to our list using the append method. Nice and simple. If the number is outside the allowed range, we show a gentle warning. Please enter a number between 1 and 10. In the next line, we have the else statement of the outer if condition. Here, if the input wasn't digits at all, we remind the user. Only numbers or "done" are accepted. At the end of the loop, we ask again for input from the user. This repeats the process until the user finally types "done." The loop ends here, when the condition is no longer true. Next is the results section. After collecting input, we check if we actually have any valid ratings in our list by using the len function on ratings list. In next line, variable total holds how many movies were rated. Then, we compute the average rating by summing all ratings and dividing by the count. At the end, we also find the best rating with max method. After that, we print a summary. How many movies were rated, the average rounded to 1 decimal, and the highest rating. If the user didn't provide any valid ratings, we display the message, "No valid ratings entered." This small program demonstrates several key skills. Input handling, while loops, data validation, lists, and basic statistics using sum, len, max, and round. It's a great template for any repeated user input task. Notice also how the while loop allows repeated input until the user explicitly ends it. This is one of the most common real-world uses of loops, handling user data. Now let's see 3 very useful statements that we can use in loops. Break, continue, and else. Sometimes you don't want to finish looping through everything. Maybe you found what you need. The break command is used to jump out of the loop immediately. With break, we exit the loop permanently. In below example, we have a list with temperatures. Using a for loop, we go through all the temperatures in the list, and using an if conditional, we check if a temperature in the list is above 40. If yes, we print the message overheat warning, and using the break statement, we exit the loop permanently. If not, we print the message, temp is safe. What happens here? As soon as a temperature goes above 40 degrees, Python prints a warning and jumps out of the loop completely. Now imagine you don't want to exit the loop, but you want to skip some values. That's where continue comes in. The continue command is used inside loops, and it tells the program to immediately skip the rest of the code in the current loop iteration and jump straight to the next one. This is useful when you want to ignore certain cases without completely breaking out of the loop. It can be used in for or while loops. Actually, continue instructs Python to skip the rest code in the current iteration. Here we have an example for the use of continue. A list called numbers contains 7 integer numbers. Using a for loop, we go through all the numbers in the list, and with an if statement, we check for negative integers. In case Python finds a negative integer, proceeds to the next iteration, and if not, prints a message. What happens here? The program will only process and print the non-negative values 3, 7, 0, 2, and 8. The negative numbers -1 and -5 are skipped silently. There's a hidden gem in Python. Loops can have an else block. An else block can be attached to for or while loops. It will run only if the loop didn't exit using break. This means that the else part runs only if the loop finishes naturally, without breaking. For example, let's say we have a list with 3 emails in it, and a variable called target that we assign an admin email to it. Using a for loop, we go through all the emails in the list. And using an if statement, we check whether the admin email is in this list. If yes, Python prints the message, admin located, and breaks the loop. In case the if statement does not find the admin email in the list, Python does not break early the loop and finishes it completely. Then the else block politely prints, admin not found. Keep this special feature. The else will only run if we didn't break out early from a loop. This is very useful for things like search or validation. In this exercise, we are searching for a special number. You are given a list of numbers. You should write a program that performs the following tasks. Scan through the list using a for loop. If the number -1 appears, stop the loop and print stopped at -1. If the number is 0, skip it, do not print it. Otherwise, print each number. If the loop finishes without finding -1, print scan complete. Let's see the code now. The first line creates a list containing 6 integers. After that, we start a for loop that goes through all the numbers in the list. Inside the for loop, we have an if statement that checks if number -1 is in the list. If yes, prints the message, stopped at -1, and breaks the loop there. If not, the loop continues with a second if statement that checks whether 0 is in the list. If 0 is found, then using continue statement proceeds to the next iteration without printing anything. If 0 is not found, it prints the number of the current iteration. Last is the else statement that will only run if the loop finishes without breaking, which means without finding number -1. So in case the loop finishes naturally, it prints the message scan complete. And that's the power of while loops combined with break, continue, and else. You've seen how loops can run until conditions change, how to exit them early, skip unwanted cases, and even add an elegant else block when no breaks occur. Together, these tools make your programs repeat tasks efficiently and handle data intelligently. But we're not done yet, because in the next part, we'll unlock nested loops and infinite loops. This is where loops get truly powerful, and you'll see how they're used in real systems. Loops are everywhere, from processing datasets to controlling robots to managing your weekend movie list. Until then, keep practicing, and remember, coding is like learning to dance. You repeat the steps until they become second nature.